All right, this lesson is on the algebra toolbox. The first topic here is on classifying numbers in the real number system. We will do an activity in class. So we have in the box here the real numbers. Within that has the rational numbers, integers, whole numbers, natural numbers, and irrational numbers. You can see off to the right side shows a description of those. And then in the box below here is that same image. So irrational numbers have decimals that do not have repeats and end. Rational numbers are decimals that do not repeat or end. Oh, that do repeat. So do repeat or end, so just cross that out. Integers are numbers like -2, -1, 0, 1, and 2. Whole numbers, we start at 0, 1, 2, 3, and increase. And the natural numbers are also called our counting numbers, so we just eliminate that number 0 and then start with the number 1, 2, 3. So again, just make sure you cross out the word not, so they numbers that do repeat. The notation that looks like this little e represents the elements in a set. So example 1, is it true that -6 is in the elements? So yes, -6 is in that set. Second one, is it true that 1/3 is in the natural numbers? So 1/3 can be written as approximately 0.3333 repeating. So natural numbers, if we go up here, natural numbers are right up here. These are our natural numbers. Natural numbers are our counting numbers. So natural numbers are not in that set. Is 1/3 a real number? Yes. So 1/3 falls right in the real number system. It falls within the rationals because it is a fraction. It would fall right inside of here because it can be written as a fraction. So that would be a yes. Is 1, 2, 3 a subset of a rational number? Yes, it is. Because if we look at a set of our boxes here, 1, 2, and 3. So here's 1, 2, and 3. It is a subset of our rational numbers. So yes. Example 2. Write the set 1, 2, 3, 4, 5, 6, and 7 in set builder notation. Graph it on a number line, and is it discrete or continuous? So how we write this in set builder notation is it cannot be written as an inequality. So it is considered discrete because it can't be written as an inequality. So how we write this in set builder notation is x with a large bar, vertical bar, and then x equals, and then we just list the numbers 1, 2, 3, 4, 5, 6, 7. And then how we graph it on a number line is 1, 2, 3, 4, 5, 6, 7. And then we just put our little dots. And I like to just write it above it. Example 3, graph the following in a number line, write it in interval notation, and then write it in set builder notation. So we're giving you it as an inequality on the left. So how we say this, x is greater than 5. I'm going to put 5 in the middle here. It's not equal to 5, it doesn't have the line underneath it. So we put a little parentheses here, and it's going greater than. As an interval, it starts at just to the right of 5 and going to infinity. In set builder, x with that vertical line such that, that's why you say that, greater than 5. The next one, inequality, x is greater than or equal to negative 3 and less than or equal to 4. So it does include negative 3 and it does include positive 4. So now we're going to have brackets on both of them. In set builder notation, we're essentially just taking that inequality and writing it to the right of that vertical line. All right, here's some more. Now we're giving you an interval notation. So I like to do the number line first. So here's our negative 3. And it's saying here that we're starting at negative 3 and going to positive infinity. So how we say this then is an inequality. It's x greater than negative 3. It does not include negative 3. Notice this is a parenthesis, so it's not including negative 3. So in set builder notation, x vertical line, so x such that x is greater than negative 3. The next one, we're giving you now the set builder notation. So these are our natural numbers of x less than 5 here. So we're going to start with 5 and go less than. So negative infinity to just before 5. So we say that this is then x, oops, just turned it to a highlighter here. Less than 5. All right, the next one is saying x cannot be negative 4. So we put negative 4 in the middle. It cannot be negative 4, so we put an open circle, and it's everything but negative 4. It's going to be to the right of negative 4 and to the left of negative 4. So how I write this in interval notation, it's negative infinity to just before negative 4. And then we put or, that's this little union, or negative 4 to infinity. And then x such that x cannot be negative 4. And I think I'm going to skip the last one because these are pretty much the same, but I'll just draw the line here. This is just 5 open circle to the right and left of 5. Well, I'll just continue. They're pretty similar. Negative infinity to 5, or 5 to positive infinity, and then x such that x cannot be 5.